Hi, long time no see. I want to check if my mic has echo. Can you please let me know in the chat? Hello? Because I'm changing a microphone. Just let me know if the mic has echo. Oh, thank you. By the way, thank you so much. Yeah, so on the right top corner, I have this command. Hey, I have this command. If you type Discord, I just create a new Discord channel for Discord server for us to stay connected. If any of you interest, you can type the command. It's on the right top corner. Yeah. How is weekend? Do you come from my email or just YouTube notification? Linux? Should I call you Linux? For my DF, how about you? I'm gonna wait for a little bit before I start. Oh, it's YouTube notification. Oh, thanks for letting me know. Oh, also. Okay. Yeah, so if you come from YouTube, basically, I want to continue this weekly live by sharing some AI foundation, basically AI from foundational ML model to prompt engineer to RAG application and AI agent and to generative AI system design. So basically, I want to share as I learn every week, and I want to learn together with you and share with you. I will mention soon in my slide, just a quick intro. So I have my slide open. Yeah. Using my, can see my screen, right? Okay. Yeah, so today I wanna just start my very first session of AI for Absolute Beginner. And for today, I wanna share some foundational, some basic thing about RAG. Basically, what is RAG? And give some example. And for next week, I'm gonna talk about some RAG application. So this week is more like a tutorial to get to know about what is RAG, and next week is more about the hands-on session. Have you heard of RAG before? Any of you? Linux or Format DF? Oh, how familiar are you with RAG? Are you building a RAG application already, or just heard other people talking about it? I'm gonna continue while waiting for you. Yeah, so why I want to start this series of new series of weekly live about AI is I realized that as ChatGPT coming out last year, and is it last year? Yeah, and as AI is getting more and more trendy, there are a lot of information going on, and a lot of people talking about they don't know how to get started, they don't know how to pivot to AI industry, and there's just too much information. And I hear like AI panic is quite common, and that's why I feel like the best thing to tech anxiety is to study and just to get started. And I noticed that a lot of tutorial or a lot of talk I've been to, they're pretty advanced. Like they already assume you have all the basic knowledge of everything, and they just directly go to a certain stage. So I find it's not very friendly for beginner, and that's why I want to have this series so that everyone, if you're just a computer science student, if you never taking any machine learning courses, if you don't do machine learning in your work, you can still learn the foundation, learn the basic, and you know. So it's like a good starting point for you. And you once you have this knowledge, you can later on learn easily catch up with any other insights. Okay, you tried it. There's a Google Dev Fest. Oh, demo at Google Dev Fest. Oh, I'm curious which Google Dev Fest you've been to, because I also went to Google Developer Group Dev Fest. Oh, which Google Dev Fest? Okay, I'll wait for you. So I have this roadmap, and it's not a concrete roadmap. It's just a view like over here. So I think there's not a simple or straightforward path from beginner to expert, because everyone, your AI niche is different, everyone's interest is different, everyone's like industry, like your interest area is different. So it's more like a exploration stage. Like it's a journey, and it's like I'm gonna share the information along the way. If you find anything interesting, you can keep explore like a mountain here or river here. So my vision for this roadmap is basically share a little bit information every week, and if you see anything interesting, you can continue explore with a group. And the weekly live format is I'm gonna continue the study session every Sunday at 9 a.m. Pacific time. So I'm not sure what time is it at your time zone, but this is the time I'm going to start. And this week I'm just start with RAG, basic RAG, and next week this follow-up I'm going to talk different aspect of AI. Next week, I'm going to talk about some hands-on session. And I'm going to get started. In Ankara. Oh, cool. What time is it at your time zone? So I'm going to get started. So I'm going to start with a scenario that you're driving and then you turn on your car, but you're greeting with this warning light on the dashboard. It's over here. And you're going to panic, was like, oh, what's going on? What should I do? Should I stop? Should I call someone? Like you're not sure what to do. And then you think about your best friend AI. And so you're thinking, okay, how about I take this picture and I send to AI, ask AI what to do. So you send this picture and you ask AI, what's wrong with my car? And AI does give you accurate, like it gives you a lot of information. It looks accurate, just like it looks correct. However, just keep in mind that if you're ask this information to AI, for example, you ask Gemini, ask ChatGPT, or any other AI application or any other AI chat. So the thing is, they don't have information with what's your car menu, what is your driving history. They don't know about you. They don't know about your history. They don't know about all the information that's associated with this car. So they're not likely to give you a very accurate answer. They probably give you a very general answer, but there's not likely to give you a very accurate answer because they don't know your car model. They don't have enough context. They don't have enough information. It's like, okay, user asking the model, what does this warning light mean on my car? And model send the answer back to the user. However, because the model only based on the pre-trained data, so the model cannot, they don't know the specialized data. They don't know the data related to your car, related to your model. So they're not likely to give you a very accurate answer. And I'm gonna draw a sad face here. That's why LLM has limited knowledge, therefore it has hallucination. I think hallucination is quite common these days, that you're asking AI question. If AI doesn't know the answer, they may likely to make up something and look right. So how to solve this problem? That's why we introduce RAG. Okay, it's 8 p.m. So it's nighttime. Okay. I'm glad the time is still friendly for you. All right, and go back to this. That's why we introduced RAG. So RAG, basically we're using retrieval backend to enhance LLM capacity and reliability. So for those of you who don't know RAG, you just need to remember one thing. RAG is you need information, you're adding this information retrieval to the basic LLM model. So originally, you asking the model the question, what does the warning light mean in my car? And model just directly answer based on the pre-trained data. But now you give this AI extra ability to retrieve data. So basically you have this external database. And so you, with RAG pattern, like LLM is able to do the information retrieval to the external knowledge base, so that user, when user asking a question, and then LLM, it's not only answer based on the pre-trained data, it's also based on the external database. That's why it can reduce hallucination. So now if the user asks the same question, what does the warning light mean on my car? A model gonna do some information retrieval with VectorDB and give the answer back to the user. So you may wonder, what is a VectorDB? Any of you know VectorDB? I'm gonna talk about what is VectorDB today. And just if you can let me know if you have any background or if you know anything about VectorDB, just let me know in the chat. I'll keep an eye on it. Yeah, so this is the definition of RAG. RAG is retrieval, augmented generation. So it's a way to use external data information, improve the accuracy of large language model. The first time I looking at this definition, retrieval, augmented generation, I'm like, this is English, but I don't know what it means. It sounds very abstract to me. But don't worry, if you have the similar feeling, don't worry, I'm gonna explain soon. So what is RAG? As I said before, is retrieval, augmentation, and generation. For the retrieval part, it is doing retrieval from database with vector search. For the augmentation part, it's integrated the retrieval chunk with the existing knowledge, and generation is eventually LLMs generate the response based on all the knowledge. And I'm going to deep dive later to explain what it is for each step. And I'm going to also talk about what is VectorDB and how exactly model is doing this retrieval, and why we're using VectorDB, why we don't using normal database. And for this information retrieval part, basically it's this part. When user asks a question and then model try to do the information retrieval from VectorDB. So this information retrieval part has two major concepts. One is embedding, another one is vector search. Okay, I didn't see anyone mention about if you know VectorDB, but I'm gonna ask another question. Anyone know embedding or vector search? If you let me know, I'm happy to. It will be really helpful for me to know what is your background. So I'm gonna continue. For RAG components, there are three major components. They're embedding, vector search, and LLM. So the embedding and vector search is mainly for the information retrieval part. And I'm going to continue. What is embedding? I'm going to start with this picture. So basically, you can see there are different types of food here. There's salad, hot dog, pizza, bullshit, and it's a different type of food. So basically, they're just different information. And the question is, we want to use something to represent the information here, and how to represent the information. Therefore, we introduced a factor here to describe all this food here by how sandwich it is. If it is very sandwichy, then we put on this side. If it's not very sandwichy, we put on left-hand side. So in this way, we are able to describe this food information with how sandwich it is. And again, you may notice that, hey, it's not very like if you simply describe the food based on how sandwich it is, it's not very accurate. So therefore, we introduce more dimension here. We introduce liquidness and dessertness, and therefore we are able to better describe the information here, so that we are able to describe all the food information here with 3 dimension, like. So for each food here, it will have a vector like embedding to represent the physical location in this space. And that point, that is embedding of this information, and that represent the meaning of the food. Yeah, numeric representation of data. That's correct. And I'm gonna have a very quick demo for embedding. Give me a sec. Anyone has any vacation plan? I'm gonna wait in the chat while I'm opening another demo. Okay, have this demo open. Stay cautious. Okay, mostly. Okay, I'm gonna stop sharing this, and I'm gonna share a demo. Yeah, so this is if you want to play, I'm gonna share this link to the chat. Basically, if you want to play around, this is embedding space represent information here, and it has 200 dimension simulated in this space. And basically, if you search something, for example, orange, and then you can find orange in the space, and you can find the nearest point in the original space, and you will notice that, hey, this yellow, green, blue, purple, they're actually close to orange in the space. And from the meaning perspective, yellow, green, blue, oops, okay. I guess I choose the yellow now. I'm gonna search orange again. Okay, I'm gonna refresh. Okay, orange. Yeah, so you can tell that yellow, green, blue, the meaning are very similar to orange. So because the meaning are very similar to orange, and actually in this space, they're physically close to orange. So we can, from this demo, you can get a feeling that, oh, if 2 points in this embedding space, if physically they're close, they actually have similar meaning. So that's how, that's the foundation of the vector search. So basically, we're trying to find in the embedding space, we get an embedding all the information, and we search information based on how close they are. So if they're very close physically, so meaning-wise, they're also very similar. So that's how you find the similar result. And I'm gonna go back to the iPad. Okay. Yes. Yeah. So from the demo, you're saying that we have this text input. In that example, we have orange, and then you're able to see there is an embedding representation of that orange. So in practice, how we do it is we actually have this model, and we fed the embedding, we fed the information to the model, and we will get the numeric representation of the meaning. So, so I'm gonna share more project next Sunday about how exactly in code, in practice, how do we actually get the embedding of the text input. And I don't have it today, but I'll share next Sunday. And I'm gonna have a practice here. So imagine something called bug. What does bug mean? Anyone has any idea what does bug mean? So anything come to your mind? I'm gonna wait for a bit. The reason I wanna, arrows. Yeah, so when you think of bug, you may think of arrows in programming, right? But however, a bug can also mean insect in garden. So this simple word can have different meanings. Therefore, that's why it's very powerful to use embedding, because in the traditional search, if we're simply using regular expression, we simply search bug in the database. You probably find a similar search that's just similar to this word. But if we get an embedding of this bug, so we have the embedding of bug in the garden and bug in the code. So bug in the code is actually close to other arrows, like Linux said. But if bug in the garden will be close to different type of insects. So that's why if you're getting the embedding and actually capture the meaning of the information, we actually can find something similar to what it actually means, not just by the character bug. So that's why it's very powerful with embedding, and that's why we are having this vector DB to search from. And this is another example here that we not only can get embedding for the text information, we can also get embedding for image information and video information. So all different type of information, we're able to get the numeric representation of that information. And again, I'm also going to share a project next Sunday about how we can get the embedding for different type of information. And now we know what is embedding. I'm going to go to the vector search part. So if you have any question, you can just put it in the chat. So for the vector search part, we have this query search and rank. So for example, if we want to search this shoes in this embedding space, we want to find the top k similar result, then how we do it is we're grabbing this embedding for the query item. And then we search in this embedding space. We're trying to find some k closest point to this query item. And then in this embedding space, physically, like if it's the point is actually close to this point, that means they're similar to the searching item. That means they're actually, so that is a top k similar result. So basically we're trying to search the top k closest point to this query item embedding. And you may wonder if we just go to this embedding space and search each of them and compare the point, like for each point we have a dimension, and then you have to check each dimension for this embedding. And then that is a brute force search. So it's very, very expensive. And in practice, we don't. So even though theoretically you should do this search so that it's more likely to be accurate, but in practice, we are actually doing this similarity search. Oh, sorry, approximate search. So basically, instead of searching for every single points in this embedding space, we only search like small region of it. That way, you're likely to reduce cost. Also, I'm going to share example about this next Sunday about how to do this approximate search in practice. And I'm going to share another demo. Yeah, so again, I'm going to put the demo link to the chat link. Okay. So here, for example, if we search by text, so this is a vector. This is a vector search. So if you search by Python, you'll notice that it's not only searched by the Python itself. It's also searched by the meaning. I can open the one example, which language are the best. And there's a way to search from text to image. So if I search cat, I will have a lot of cat information here. So basically we have this joint embedding space that we have all different type of information. We have the embedding for the all different type of information. We have the embedding of this cat, which is a text input. And also we have embedding of those image information. so that if they're all in the same drawing space and they're actually physically close to each other because they all means cat, because their meaning are very similar. So that's why you can search from text to image really fast. And similarly, you can search from image to image. I'm not gonna show it here. And I'm gonna come back to the slide. Okay. Yes. Yeah, so this example, I have my dog. So it's like she's sitting, laying in front of a laptop. And then this is a description of what is going on in this image. And they're all in this drawing embedding space. And they're actually physically close to each other because the meaning are similar. So imagine if I have a drawing embedding space, I'm able to search from this image to the text and text to image. If I grab the embedding of this image information and text information, and that way I can do vector search in this embedding space. So in summary, for RAG, we have information retrieval part. When we do the vector search, we have chunks retrieved from vector search. So for example, when we query something, and this is top case similar result, those are chunks result from the vector search. So we have this chunks retrieved from vector search, and then it fed to LLM. So the second stage is it will augment the existing LLM knowledge, which are pre-trained knowledge, with the information that wasn't trained. So this information are just coming from the chunks that retrieved from vector search. And eventually, when they have all the information that coming from vector search and existing LLM, you're going to generate a response that more likely to be accurate because it is based on retrieved chunks and pre-trained knowledge. That's why RAG can reduce hallucination. And also it kind of, so why RAG called RAG? It's because it's including retrieval, augmentation, and generation. And basically, we do the vector search, we retrieve information, augment the existing knowledge, and then generate the response. And just come back to the previous slide about information retrieval. We have this embedding and vector search. Embedding is to capture the meaning of everything, and vector search is based on the meaning. You can actually find the physical point, in the embedding space, and you're able to find the points actually physically close to each other in that embedding space. That's how you do vector search. So those whole two steps are information retrieval part for RAG. And then we have augmentation. Once we have the chunks retrieved from vector search, you can either enhance the original prompt or improve the context and relevance so that you can augment the data. And again, I'm going to show this in project in the coming weeks. And this week is mostly just sharing some theory. This is the coming back to this, coming from chunks retrieved from vector search, and then augment existing, and then generate. All right, so I'm coming back to the original question. The question that I'm trying to send in this car information to the to AI and ask AI what's going on with the car. So if with a standalone LLM, the model just simply return the answer, but it may not likely to be accurate. And with RAG, this is a simple RAG. we have all different type of RAG, but this is a very basic demonstration. It's a basic one, but it doesn't mean every RAG is like that. It's just an example. So user asking, what does this warning light mean on my car? And user has this question input, and then we get the embedding of this query. So basically, we get embedding of the question, what does this warning light mean in my car? And then we are trying to do the vector search, and with approximate nearest neighbor, that is to save cost in this vector DB. And eventually, we are able to have this document chunks and image result from this fetching. And this is the chunks retrieved from external knowledge base. Basically, this is all like information retrieval part. And then once I got these chunks, I'll send it back to LLM, and this is doing augment. So this part is doing augmentation. Basically, I'm augmenting existing LLM information with this chunk, so that it's able to generate a more likely to be accurate answer. And then it's generate this answer and send it back to the user. So this answer is based on the pre-trained knowledge and also retrieved information. Therefore, it's more likely to be accurate. I'm gonna pause here since we don't have any question. Yeah, so for today's session is mostly trying to share the basic of RAG. What is RAG, and what information retrieval mean in RAG, and what is how does RAG can reduce hallucination from a simple model. And for our next week, I will do some recap, and I will share some hands-on project about RAG, and I will also talk more about agent, talk more about some generative AI system design question. And if you have any question with today's slide, or if you want a copy of today's slide so that you can read it by yourself, you can join the Discord channel to discuss together. So the way to join Discord channel is you go to the top right corner. You can see, you can type Discord. So if you type Discord, you're able to see the invitation link. Yeah. And yeah, for those who sign up through the newsletter, I can also send today's recap to you to your email. Yeah. Anyone? I'm gonna just stay here for a little bit. Moving to okay. Thank you so much for everyone who coming today. Really appreciate it. It's so nice to see you, Linux, again, and see you again. Yeah, I remember last time it's half years ago or a couple months ago. I forgot. I'm so happy to see familiar face. I'm gonna stay here for a little bit just to study and see if any of you have any questions. Thank you. Thank you, Xuan Rui. Oh, thank you, Starwise. Share the newsletter link. If you go to here, okay. If you go to my Luma page, let me open it. If you go to my Luma page and you click subscribe, and I should have your email and I can send it to you. Okay, I'm about to drop, and thank you so much for coming. See you next week. Bye.